In this video, we'll be focusing on solving an IB physics problem about electricity and magnesium. So this is for Physics SL Paper 1 problem. What is correct about the power dissipated in the resistors? So which resistor dissipated the greatest power in the circuit? So we know power is equal to voltage times current, which is equal to current square times resistance. Since they all have equal resistance, you only need to find out which resistor receives the largest current from the battery terminal. So if here is current I, then because there's current, their resistance are equal, here must be a half I, and then here will be I again. For this part here, the above have a resistance of 2R, the below has a resistance of 2R. Because they are in parallel, so they must have the same voltage. So 2R times R1 is going to be equal to R times R2, which means 2AI is going to be equal to I2. And the total current is I. Right. So for 2R, there's going to be a current of 1/3 times I. And for the bottom part here, I2 is going to be equal to 2/3I. And here has a half I, which is equal to 0.5I. This is equal to 0.67I. This is equal to 0.33I. So here has the greatest current, which is for resistor Z. So C is the correct option. The electromotive force of a cell is defined as what? So this is just basic definition of electromotive force. It is defined as the power supplied by the cell per unit current from the cell. A current is established in a coil of wire as shown below. The direction of magnetic field at point P is what? So if you curl your finger in the direction of the current, your thumb will be pointing out of the screen. So inside the current, the magnetic field point out of the screen. So outside the coil of currents must be pointing into the page. So for point P, it's gonna be pointing into the page. So B is the answer. A cell with negligible internal resistance is connected as shown. The ammeter and the voltmeter are both ideal. What changes occur in the ammeter reading when the mode and the voltmeter reading when the resistance of variable resistor is increased? So if the current of variable resistor IV increases, resistance. So if RV increases, because it's in series, then we know our sum of the resistance increase. And because resistance increase, current is gonna decreases. And this resistor here R is fixed. So if the current goes through the resistor decreases, then the voltage must be decreasing. And here the battery supply a electromotive force, which is a constant number if there's no internal resistance, and because VR decreases, then the voltage of the variable resistor must increases. And here the voltmeter measures the voltage of the variable resistor, and ammeter measure current in the circuit. So current is gonna be decreasing and voltage here is gonna be increasing. So the answer will be C. which diagram best represents electron flow due to a negative charge conducting sphere? So it's gonna radiate inward. B is the correct answer because here there should be no electron flow inside the conducting sphere. The circuit shows a resistor R connected in series with a battery and a resistor of 10 ohm. It has a negligible resistance, internal resistance. The current in the circuit is 1.0 ampere, which is the following is the resistance of R. So here, current of 1, resistance of 10, so it's gonna have a voltage of 10. Sorry. Then here the voltage will be 10. Resistance is gonna be equal to 10 over 1, which is equal to 10. So C is the answer. Three identical resistors are connected to a battery as shown. Which of the following is a correct statement? So the current through I is greater than current through Z. This is not correct because here will be the total sum of current. Here let's say I1, I2. So I1 plus I2 is gonna be equal to I. The potential across D is greater than the potential across Y. So Z and Y. This is also not correct because obviously current I2 is gonna be less than I, while their resistance remain constant, remain equal. So voltage of across the potential difference across D is greater than the across Y. Also B is correct, sorry. The potential difference across resistor X and Y together is same as the across D. So because the resistance of X and Y are equal, then currents through resistor X and resistor Y is gonna be equal. That's called IR. So they're gonna have a same voltage, right? So C is not correct. D, the current through Z is less than the total current through X and Y. So the current through this is also not correct because I1 plus I2 is equal to I. The diagram shows two current carrying wires, P and Q, that both lie in the plane of the paper. The arrow shows the conventional current direction in the wires. The electromotive force on Q is in the same planes as that of the wires. What is the direction of electromotive force acting on Q? So, the direction of electromotive force acting on Q. So here, the current is flowing to the right direction. So you're gonna have a magnetic field that pointing out of the page here, and pointing into the page here. And for this current, you're gonna have a magnetic field that point out of the page here into the page here. So here the magnetic field cancels off. You only have current flowing in this direction, magnetic field pointing into the page. So we'll have a force that's pointing upward. So this is A. A positively charged particle moves parallel to a wire that carries a current upward. The direction of the magnetic field on the particle is Y. So if you put your thumb in the direction of the current and rotate your finger, you will find out the magnetic field pointing out of the page here and into the page here. So it's gonna be something like this. So it's rotating counterclockwise. So it's rotating counterclockwise. So now, how you can solve the problem? So for this type of problem, draw a straight line between the current and the wire and set this as radius r, and then just draw a circle. And because we know it's counterclockwise, so it's gonna be this direction. and the direction of magnetic field at a point is just a tangent line, right? So the magnetic field will be pointing upward here, right? So now you need to determine the direction of the magnetic force on the particles. Actually, it doesn't have to be so complicated, right? So just here is pointing out of the page, here is pointing into the page, and this is the direction of current. And then you can determine the direction of magnetic force. So it's gonna be pointing to the left. An electron traveling at speed v, perpendicular to a magnetic field of strength B, experience a force F. What is the force acting on the alpha particle traveling at a speed of 2v, parallel to a magnetic field of strength of 2b? So this is gonna be equal to 0 because they're parallel, and sine 180 degrees is gonna be equal to 0. An electron is accelerated through a potential difference of 2.5 milliwatt. What's changing kinetic energy of the electron? So changing kinetic energy is going to be equal to work done by potential difference, which is equal to 1.6 times 10 to the negative 19th power times 2.5 times 10 to the 6th power. And this is equal to 4 times 10 with the power of negative 13. Yeah, I think this is correct because this is equal to 4 times 0.4. 4 times 2.1 is going to be equal to 1. Times 0.4 is going to be equal to 0.4. Here is going to be equal to negative 25. So this is gonna be equal to 0.5 times 10 with the power of what? What's the power of? So let me plug this into my calculator in case of any error. Oh, sorry, here is positive 6. I was misleading myself. So this is going to be equal to 0.4 times 10 with the power of negative 13. Right. So it must be, the answer must be C. Which of the following diagram illustrates the electric field pattern of a negative charge sphere? So it's A. Because the electric field is gonna radiate inward. There should be no electric field inside the sphere. A positively charged particle enters space between two charged conducting plates with constant velocity directed parallel to the plate as shown. The two plates positive charge. On the top plate is positive charge and the bottom plate is negative charge. There is a magnetic field shedding in shed area, region PQRS. The particle continues to move in a horizontal straight line between plates. Which of the following correctly describe the magnetic field direction? So here is the positive charge particles, and we know there's gonna be an electric field. So the particle will receive a force due to electric field, which is pointing downward. So in order to move in a straight line, then that force must be equal to 0. So the magnetic field must be pointing upward. Now you need to find the direction of electric field. Magnetic field. So this is force. This is velocity. So how can we get a force by putting upward? So the electric field must be pointing into the page. A beam of electron moves between the poles of a magnet. What's the direction in which electron will be deflected? So velocity is pointing into the page. The magnetic field pointing from the north pole to the south pole. So now I can find the force, direction of force. So it's gonna be upward. However, because it's electron, so it's negatively charged, so the force will be pointing downward. A cell has a EMF of 5.0 volt and an internal resistance of 2 ohms. The ideal voltmeter reads 3.2 volt. What's the resistance of R? So it lost a voltage of 0.8 volt from the battery terminal to the resistor, which must be caused by internal resistance. Right. So imagine there's resistor here, representing the resistance of the internal resistance. So VR is gonna be equal to 0.8 volt. And we know the resistance here, so we can calculate current. 0.8 over 2 is gonna be equal to 0.4. What's the unit of ampere? So here, what's the resistance of R? You know the voltmeter here measures the voltage of resistor R. So 3.2 volt over 0.4 is gonna be equal to 8. So the answer is D. Three resistors are connected as shown. What's the volume of total resistance between X and Y? So X and Y can be this here, 2 ohm, but it doesn't have the option of 2. So what is the answer? So X and Y can also refer to here. Right. And we know this resistor here and this resistor here is connected in parallel. So the sum of their resistance is going to be equal to 3 times 3 or 3 plus 3, which is equal to 9 over 6. So it's going to be equal to 2 over 3, which is equal to 1.5. So the answer will be A. Two resistors X and Y are made of uniform cylinder of the same material. X and Y are connected in series. X and Y are of equal length, and the diameter Y is twice the diameter of X. What's the resistance of this series combination? So the resistance of R is of Y is R. Right. So resistivity times length over area of Y is equal to R. And here has a diameter of D. Then here's gonna be a half D. So area, cross-sectional area of resistor X is gonna be equal to pi. Actually, let me do this. Resistor X has a diameter of D, and resistor Y has a diameter of 2D. So area is equal to pi r squared. So D over 2 squared is gonna be equal to pi D squared over 4. So this is the cross-sectional area of resistor X. And the cross-sectional area of resistor Y is gonna be equal to pi times D 2D over 2 squared, which is equal to pi D squared. So AX over AY is gonna be equal to pi d square over 4 times pi d square, 1 on the top. So here we'll cancel saw. So this is going to be equal to 1 over 4. So assume ay is equal to a. Then ax will be equal to 1 over 4a. Right. So for calculation, because I want to make it easy, so I'm going to say ay is equal to 4a. Ax is equal to a. Right. So resistivity times length times 4a is going to be equal to r. Then resistivity times length times a is going to be equal to 4r, right? Because here is 4 times larger than this quantity here. Now I can calculate sum of their resistance is going to be equal to r plus 4r, which is just equal to 5r. So the answer is D. A material where X was length L and radius R has resistance R. A wire Y of length 4L made from the same material as Y has same resistance R. What's the radius of Y? So they both metal where X has a length L and radius R, and resistance R. Another one wire Y has a length of 4L and same resistance. What is radius of Y? So Rx is equal to Ry, and which is equal to resistivity times length over R squared. So our area is going to be equal to pi R squared, which is equal to resistance of where Y. So resistivity times length, so 4L over pi Ry squared. So this cancels out on both sides. So 1 over R squared. Square also cancels out. So 1 over R is going to be equal to 4 over Ry, which means Ry is going to be equal to 4R. So the answer will be B. A cylinder resistor of length L is made from metal mass of mass M. It has a resistance R. 2 resistors, each of length 2L and mass M2, are then created from the same volume of the metals. What is the resistance of the 2 resistors connected in parallel? So here, resistance is going to be equal to resistivity times length over area. Because length is double, then the resistance is going to be double. So it's going to be equal to 2R. And then because created from the same volume of the metal, then the area will also be changed since the length is changed. So volume is equal to area times length, which is 2L. So area is going to be equal to V over 2L. Initially, volume is equal to A times length. So area is just going to be equal to volume over length. So this is area is decreased by a factor of 2. And if area is decreased by a factor of 2, then the resistance will also be double. So now you have a resistance of 4. So now I can calculate the resistance of 2 resistors when connected in parallel. So each of them has a resistance of 4R. Then the total resistance will be equal to what? So it's going to be equal to 4R times 4R over 4R plus 4R, 16R squared over 8R is going to be equal to 2R. So the answer will be B. 2 rectangular blocks X and Y of the same material have different dimension but same overall resistance. Which of the following equation is correct? So resistivity times length of X is equal to resistivity times length of Y. This is wrong because resistance is equal to resistivity times length over area. Right, so you're not sure about the area here. Length X over cross-sectional area of X is equal to length of Y over cross-sectional area of Y. This is correct because they all have the same overall resistance and they have the same resistivity, so B is correct. They are made of same material, so resistivity must be equal. C says resistivity times cross-sectional area of X is equal to resistivity times cross-sectional area of Y. This is not correct. D, length of X over cross-sectional area of Y is equal to length of Y over cross-sectional area of X. This is also wrong. A cell of EMF has an internal resistance R, deliver currents to a small electric motors. So 450 coulomb of charge flow through the motor, and 9,000 joule of energy are converted in the motor. 1,800 joule are dissipated in the cell. The EMF of the cell is Y. So here is Q, here is energy, here is another energy. So let's call this energy of internal resistance. So how do we calculate this problem? So here's a positive terminal. Charges flows through the motors, and 9,000 joule of energy is converted. 108,000 joules are dissipated in the cell. So the total energy, E total, is gonna be equal to 9,000 plus 1,800, which is gonna be equal to 0.0810 joule. Right. So here is 9. So energy is equal to power times time, which is equal to voltage times current times T. So here is gonna be charge, so it's equal to voltage times charge. So in this case, it's gonna be equal to the EMF times the charge. Since we consider V plus the energy dissipated in the cell is equal to, which is equal to this number here. And we know charge is equal to 450. So now we can calculate EMF. Alright, and then you should get an answer of 24. So the correct option is D. A resistor of resistance 12 ohm is connected in series with a cell of negligible internal resistance. The power dissipated in the resistor is P. The resistor is replaced with a resistor of resistance of 3 ohms. What is the power dissipated in this resistor? So from 12 ohms to 3 ohms. The resistance is divided by 3, which means the current is gonna be multiplied by 3. So if here has a current of I, here's gonna be 3I. And power is equal to voltage times I. Right? So because here they all connected to a cell. So which means voltage remain constant. So if the current, here should be 4. So the resistance is divided by a factor of 4. So current will be multiplied by 4. So if current is multiplied by 4, then power will also multiply by 4. So the answer will be D. A proton is accelerated from rest through a potential difference of 1000 volts. What is the potential difference through which a alpha particle must be accelerated to gain the same kinetic energy as the accelerated proton? So changing energy, kinetic energy, is equal to work done by the potential difference, which is equal to, so let's do this. Changing kinetic energy is going to be equal to charge times potential difference. So proton has a charge of E. Potential difference is going to be equal to 1000. So the charge of a alpha particle is going to be equal to 2E. Right? So if electron has a charge of 1, alpha particle has a charge of positive 2. So I'm just going to use symbol to represent this. And times is potential difference. So E cancels out. So 1000 will be equal to 2V. So V is going to be equal to 500. So the answer will be C. In the circuit shown, the fixed resistor has a volume of 3 ohms, and the variable resistor can vary between 9 ohm to 10 ohms. The power supply has a EMF of 12 volts and negligible internal resistance. What is the difference between the maximum and minimum volume of voltage V across a 3 ohms resistor? So here. So let's calculate the maximum voltage across the 3 ohm resistor first. So for maximum voltage, the variable resistor gonna have a resistance of 0 ohm, which means that here the voltage is gonna be equal to 12 volt. And for minimum volt, variable resistor is gonna have a volume of resistance of 10 ohms, so the total resistance is gonna be equal to 12 ohms. Then the current through the circuit is gonna be equal to 12 volt over 12 ohm, which is gonna be equal to 1 ampere. Then the current through this resistor here is gonna be equal to 3 ohms times 1, which is equal to 3 volt. So the difference is gonna be equal to 12 minus 3, which is equal to 9 volt. The diagram shows 2 equal and opposite charge that are fixed in place. At what point is an electric field directed to the right? So X and Y, so let's just pick a point here. Negative charge, electric field radiate inward, so it's gonna be pointing in this direction. Positive charge, radiate outward, is gonna be pointing in this direction. E minus E plus. Let me change the color for the positive charge. So electric field due to the negative charge is gonna be equal to KQ over R1 square. So I'm just gonna take the magnitude here, and E plus is gonna be equal to KQ over R2 square. And because R1 is less than R2, then E minus will be greater than E2. So the electric field is going to point to the right in the position of X. So X, right. What about Y? So here, let's say it's Y. Electric field is going to radiate inward of a negative charge and outward for a positive charge. So it's gonna radiate in the direction of y. The electric field is gonna point in the left direction. And for Z, so for negative charge, it's gonna radiate inward, so it's gonna point to the left. And for positive charge, it's gonna radiate outward, so it's gonna point to the right. So now, again, let's do the same thing. Electric field due to the positive charge is gonna be equal to KQ over R2 square. Due to the negative charge, it's gonna be equal to KQ over R1 square. So R2 is the distance here, R1 is the distance here. So R2 is less than R1, so E plus is gonna be it's gonna be greater than EY. It's gonna be greater than E minus, so it's also gonna point to the right. So the answer will be C. Right. A wire carrying current I is at right angle to a uniform magnetic field strength of a magnetic field of strength B. A magnetic force Fx exerted on the wire, which force acts when the same wire is placed at the right angle to a uniform magnetic field strength to B when the current is equal to I over 4. So force from here, F is gonna be equal to current times length times B field times 19 degree, which is equal to 1, so it's equal to ILB. And now it's become 2B, so I is equal to I over 4 times 2B times the same length, so still times all, times 9 sine 90 degree, which is equal to 1. So this is gonna be equal to ILB over 2, which is gonna be equal to F over 2. So the answer is B. So when current is divided by 4, the force will be divided by 4, right? So it's gonna be F over 2, but because the field is multiplied by 2, then the force will be multiplied by 2. So F over 2 times 2 is gonna be equal to F over 2. F over 4 multiplied by 2 is gonna be F over 2. A negative 5 microcoulomb charge and a 10 microcoulomb charge are a fixed distance apart. Where can the electric field be 0? So if it is placed at position 1, the positive charge here is gonna have a electric field that radiates outward, so it's gonna be radiating in this direction. And the negative charge is gonna radiate inward, which is gonna be in this direction as well. It's gonna point to right instead of left. So this is E minus, and this is E plus. So E plus is gonna be equal to K times 10 over R plus square, while E minus is gonna be equal to K times 5 over R minus square. So I'm just taking the magnitude of electric field for the problem now. And for here, it should be microcoulomb, but I don't really care about the unit here since all the charges in microcoulomb. So here we know R plus is less than R minus, right? And here, let's say this Q plus and this is Q minus, and Q plus is larger than Q minus, which means that E plus will always be greater than E minus, in position 1, so the electric flow cannot be 0 here. Right. So position 1, electric flow cannot be 0. In position 2, positive charge is gonna radiate a outward electric flow, so pointing to the right. Negative charge is gonna radiate inward, so also pointing to the right. Right. So this part, it also cannot be 0. For this position 3 here, positive charge is gonna radiate outward, so to the right, and negative charge is gonna radiate inward, so to the left. E minus is gonna be equal to KQ minus over R minus square. E plus is gonna be equal to KQ plus over R plus square. Q minus is less than Q plus. Q minus R minus is less than R plus, so electric flow can be equal to 0 in this position. Position 3 can have a electric flow of 0. Right. So let me just recheck for position 2. So positive charge is gonna radiate outward, so in the left direction, this is correct. Negative charge is gonna radiate inward, so on the right direction. Positive charge radiate outward, also on the right direction, so it cannot be 0. So the answer will be C, position 3 only. Three positive charges of equal magnitude are held at corner X, Y, and Z of a right angle triangle. The point P is at the midpoint of XY. Which of the arrows shows the direction of electric flow at point P? So it's all positive charge. So all of them is gonna radiate outward. And here's gonna have electric flow. This direction, this direction. And because here's in the midpoint, then this distance here will be this distance, which means that electric flow due to point X is gonna be equal to electric flow due to point Y. And because they're equal, so electric flow will be cancelled out. So there's only gonna be one electric flow due to point Z. Right. So B is the answer for this problem. An electron enters a vacuum space between two oppositely charged particles with velocity v. The electron is followed by an alpha particle moving with same initial velocity as the electron. A uniform magnetic field is directed out of the page, out of the plane of the paper. The electric path is undeflected. The path of the alpha particle will be deflected out of the plane of the paper, or undeflected, or deflected upward or downward. So here we have an electron, and it has a velocity, rightward velocity. So the magnetic force is gonna point upward, right? So it's gonna point downward if it is a positive charged particle, but because it is a negative charged particle, electron is negative charge, the force is gonna be pointing upward. Right. So this force here is gonna be pointing upward. So let me draw the whole thing in red. So in order to be undeflected, there's gotta be another force pointing downward that balances out, and this force must be due to electric flow, right? Because between two positive charged electric flow, there's gonna be a force due to electric flow. And because force due to electrofield is equal to charge times electrofield, and electron is negative charge, so the force will be pointing in the opposite direction of the electrofield, which means the electrofield must be pointing upward. So on the bottom is going to be positive charged. The bottom plate is positive charge, and the negative charge, the top plate here is going to be negative charge. Sorry. So now I can do the same thing for the alpha particle. So alpha particle is positive charge, which means the force due to electrofield is going to be in the same direction with electrofield, so pointing upward. For the magnetic force, is pointing out of the page. I mean, the magnetic field is pointing out of the page, so the force will be downward. So it also will remain undeflected. So this, you can solve the problem by using analyze the force, but there's a quicker way of doing this. So let me erase all of those. So another easier way of solving this is the following. So force due to magnetic field is going to be equal to charge times velocity times magnetic field times sine theta. And force due to electrofield is going to be equal to charge times electrofield. And because of both charge are negative, right? Electron is negative charge, and it remain undeflected. Force due to electrofield must be equal to force due to magnetic field, and those two forces will be pointing in the opposite direction because the charge is negative, right? So the direction is going to be, here is going to be negative, right? So they will be pointing in the opposite direction. So if the electron remain undeflected, then the alpha particle will also remain undeflected, right? So you just think about this in a mathematical way, right? Let's say this is Fe, this is Mg, force due to magnetic field, and now you are just saying, oh, the charge here is positive, so just taking the opposite volume, so the direction will simply be reversed. Right? So you don't really need to do a bunch of force analysis. As long as you realize this, you can just solve the problem. A liquid that contains negative charge carrier is flowing through a square pipe with side A, B, C, D, and D. A magnetic field acts in the direction shown across the pipe. So it's pointing to the left. On which side of the pipe does a negative charge accumulate? Okay. So this is a negative flow of direction, so it's flowing out of the page. This is the direction of B field. So what's the direction of magnetic force here? So you can do this by using left-hand rule. So it's gonna point downward if it's a positive charge, which means for negative charge, it's gonna point upward. Right. So it's gonna point upward for a negative charge particle. So let me just double check if this is correct. Yeah, it's gonna point upward. So A will be the answer. Negative charge will accumulate. Right. An electron enters the region between two charged parallel plates, initially moving parallel. Electron enters the region between two charged parallel plates, initially moving parallel to the plate. Okay. The electromotive force acting on the electron causes electron to decrease horizontal speed, increases horizontal speed, is parallel to the field line and in opposite direction of them, is perpendicular to the field line. Okay, so how do we solve this problem? So there's gonna be a force due to electric flow, and there's also gonna be a force due to magnetic flow. So the electromagnetic force acting on the electron is gonna be Y. So we know for electromagnetic force, E field is perpendicular to B field, is perpendicular to magnetic field, and we know that E field, force due to E field, so force due to electric field is in the same direction of force due to magnetic field. So let me wrote this FB. So electromotive force acting on the electron is gonna be Y. So it's not gonna cause electron to decrease its speed, because the electron is initially moving parallel to the speed, to the plate, which means the net force is equal to 0. Is equal to 0. So force due to electric field is equal to force due to magnetic field. So the horizontal speed will not be increased as well, since the net force is equal to 0. It's parallel to the field line and in the opposite direction of them. So the force here is gonna be parallel to the field line, and in the opposite direction to them. Right. So C is the correct option. Two resistors made of same material. The length of resistor X is twice that of resistor Y, and X has twice the cross-sectional area of Y. Which of the following gives the ratio of resistance of X over the resistance of Y? So if the length of resistor X is 2L, then Y will be L. X has twice the cross-sectional area of Y, so Y is gonna have a area of A, while Y has an area of A, and X is gonna have an area of 2A. So now we can calculate the ratio of them. So Rx over Ry is gonna be equal to resistivity times 2L over 2A over resistivity times L over A, which is gonna be equal to resistivity times length over area times resistivity times length over area. So this is just gonna be equal to 1. Right. Alright, so now let's do the next problem. A positive 3 coulomb charge and a negative 4 coulomb charge are a distant x apart. P is a distant x from the 3 coulomb charge on the straight line joining the charges. What is the magnitude of the electrical strength at P? So here's P. So there's gonna be two electric flow, one due to the positive 3 coulomb charge, another one is due to the negative 4 coulomb charge. And positive charge here is gonna electric flow is gonna radiate outward, which is gonna pointing to the left direction. And negative charge is gonna radiate inward, which is gonna point to the right direction. And now we can calculate them. So E plus, so here I'm just gonna calculate the magnitude. It's gonna be equal to Coulomb constant, which is equal to 1/4 pi times epsilon times the charge here. So positive 3 coulombs over the distance between the charge and point P, x squared. E minus is gonna be equal to Coulomb constant, so 1/4 pi epsilon times the charge here. So I'm just taking the magnitude, so I will ignore the negative sign here. Over x squared, 2x squared, I mean, right? So this is gonna be equal to 1/4 pi epsilon times 4/4x squared, and the 4 can cancel off. Shoot. Right. So now I can calculate the net electric flow. So here C simply is coulomb, the unit of charge. So I'm gonna erase that for now. So the net electric flow is gonna be equal to what? So the net electric flow is gonna be equal to negative EX plus EX. So sorry, it should be equal to negative E plus EX, which is just gonna be equal to, so take the common term out here, times negative 3 over R squared plus 1/R squared. So here is gonna be equal to 1/4 pi epsilon. Here should give us a volume of negative 2/R squared. So 2 and 2 cancels off. So this is gonna be equal to what? This is gonna be equal to 2 pi epsilon x squared, and here is 1 negative charge in front, a negative sign in front. Because you're calculating the magnitude, so you will just take the absolute volume here, so you don't need the negative sign here. So this will be B. The answer is B. What is the definition of electric current? The ratio of potential difference across a component to the resistance of the component, the power delivered by a battery per unit potential difference, the rate of flow of electric charge, the energy per unit charge dissipated in a power supply. So the answer is A. Alright, I is equal to charge over T. So it refers to the rate of electron flow, or you can say rate of flow of electric charge in a circuit. The magnetic flow produced by a current in a straight wire is in what? Is in the same direction as the current, is in the different direction to the current, is in the same plane as the current, any plane perpendicular to the current. So let's say here's current I. Then here is gonna pointing outward. Here's gonna point out of the page, and here's a magnetic flow will point into the page. But for I cannot draw a three-dimensional picture, but basically it's just gonna rotate around the wire. Okay? So manifold of a current in a straight line is gonna be like in a circular loop, right? And the direction of current at a point is just a tangent line. Right? So here's gonna be pointing into the page, here's y pointing out of the page, and here's gonna be this direction, here's gonna be this direction. So is any plane perpendicular to the wire? The answer is D. Which of the following will not give rise to a magnetic field? A moving electron is gonna give an electric field, a magnetic field. Neutron, it will always give rise to, is neutron. So here neutron has a charge of 0. So it will not give rise to a magnetic field. Proton, electron moving away from each other, this will give rise to a magnetic field. Proton, electron moving towards this will always give rise to a magnetic field. So B is the answer because neutron has a charge of 0. 1 electron volt is equal to what? So this is just a basic definition of electron volt. It is equal to 1.6 times 10 with the power of negative 19 joule, right? So is equal to electron volt is defined as when a charge equal to electron is passing through a potential difference of 1 volt, which is equal to 1.9 times 10 to the negative 19th power joule. An electron passes through the north pole of a bar magnet as shown. What is the direction of magnetic force on the electron? So the field line of magnetic field is drawn like this, from north pole to south pole, and from south pole to north pole inside. Right. So here, electron is moving in this direction, and the magnetic field is pointing this direction. So what is the force here? So the force will point into the page if it is a positive charge, but because it is a negative charge, then the force will the force will point into the page, yeah, because it's a negative charge, so it's gonna point out of the page. So B is the answer. A battery terminal of resistance 2 ohms is connected to a external resistance of 10 ohms. The current is 0.5 ampere. What is the EMF of the battery? So EMF is equal to current times resistance of the circuit, and the resistance needs to include internal resistance as well, which is equal to 0.5 times 10 plus 12. So it's gonna be equal to 6 volt. So the answer is C. A battery of 6 volt is connected to a 2 ohm resistor. The current in the circuit is 2.0 ampere. The internal resistance of the battery is Y. So it's connected in series. Yeah. So you can visualize this by drawing a circuit. But I'm not gonna do this just to save some time. So battery is 6 volt, connect to, so voltage of the resistor is gonna be equal to 2 times 2, which is equal to 6 volt, right? So the voltage due to the internal resistance is gonna be equal to 6 minus 4, which is equal to 2 volt. To calculate the internal resistance, internal resistance, so R is gonna be equal to VR. So voltage of internal resistance over current, which is equal to 2 over 2, so it's going to be equal to 1. Coulomb's law refers to electric charges that are in what? Any object, charge, hollow sphere, charge, solid sphere, point charge. The answer is D. This is how the definition of Coulomb's law. So the force between 2-point charge is equal to Coulomb constant times charge 1 times charge 2 over r squared, where r is the separation distance between two charges. An electric circuit consists of three identical resistors of resistance R connected to a cell of EMF and negligible internal resistance. What is the magnitude of current in the cell? So current is equal to EMF times R sum. So R sum for this problem, calculate the resistance of this part first. So R times R over R plus R is going to be equal to R over 2, and then plus this sum. So now you can see them as one resistor. What's the resistance of R over 2? So R plus R over 2 is going to be equal to 3R over 2. So this will give us a current of 2 EMF over 3R. So B is the correct answer. Three resistors of resistance R are connected in parallel across a cell of electromotive force V that has a negligible internal resistance. What is the rate of at which the cell supply energy? So what is the rate which the cell supply energy? Basically is asking you to calculate force, right? Because rate is equal to energy over delta T, which is equal to power, and power is equal to V times I, which is just equal to V squared over R. So we need to calculate sum of resistance. So three resistors are connected in series, parallel. So 1 over R sum is equal to 1 over R plus 1 over R plus 1 over R. So R sum is going to be equal to R over 3. So this is going to be equal to V squared over R over 3, which is equal to 3V squared over R. So the answer will be D. The diagram shows two long wires X and Y carrying identical current in the same direction. The direction of force experienced by Y is Y. So they all have a current upward. So the magnetic field here is gonna point out of the page into the page here, and for Y it's gonna be point out of the page here into the page here. So to know this, just point your forefinger in the direction of the current, so pointing upward. Point your thumb upward in the direction of the current, and then curl your forefinger, right? And you will find out that your forefinger will point out of the page here into the page here. So another way of remembering this is upward current always has a magnetic field in counterclockwise direction. Alright, anyway, so here inside the two current, the magnetic field will cancel out. So the current here only has a magnetic field that point into the page. So the force will be pointing to the left. A Cooper wire with length L and radius R has a resistance of R. What is the radius of Cooper with length L over 2 and resistance R? So resistance is equal to resistivity over length over area, which is equal to pi R squared. So here is equal to resistivity times L over 2 times area. And this is just equal to what? So resistivity cancels out, L cancels out, pi cancels out. So area here is also gonna be equal to pi R sub C, so radius of Cooper square. So this is gonna be something like this. 1 over R is gonna be equal to 1. So R will go down here. So it's gonna be equal to 1 over 2 RC square. So R also cancels off. Right. So 2 RC. Oh, sorry, you cannot cancel all the score here. Sorry. So 2RC square is gonna be equal to R square. RC is gonna be equal to R square over R with the square root, which is equal to R over square root of 2. So the answer is C. Ampere is defined of what? Power dissipated in a wire of known lengths, cross-sectional area, resistivity, so this is wrong. So the correct answer is D. Ampere was firstly defined as a constant volume between two parallel current carrying wire of infinity lengths that are separated by a distance of 1 meter. So D is the correct option. And then they find out the current is rate of flow of electric charge. So I know B must be a popular choice, but just be aware that ampere was firstly defined in terms of force per unit length between parallel current carrying conductor. An electron has a kinetic energy of 4.5 times 10 with the power of -10. What is the equivalent volume of this energy? So you need to convert joule to electron-volt, which is so you just need to divide it by a unit of 1.6 times 10 to the negative 19th power. This is going to be equal to 3 with the power of 9 electron-volt, right? So A is not correct. The correct option will be D. So be familiar with the prefix. A cell is connected in series with a resistor that supplies a current of 4 ampere for a time of 500. During this time, 1.5 kilojoule energy is dissipated in the cell, and 2.5 kilojoule of energy is dissipated in the resistor. What is the EMF of the cell? So a cell is connect in series with a resistor that supplies 4 ohms at a time of 500. And energy 4.5. What is total energy? So you can calculate the total energy of the circuit first. So 1.5 times 2.5 is gonna be equal to 4 kilojoule, which is equal to energy. And energy is equal to voltage times I times D, which is equal to voltage times charge. And we know the current in time here. So charge is gonna be equal to 4 times 500, which is gonna be equal to 2,000. Right. So now I can calculate voltage, but you need to convert kilojoule to joules. So 4 times 10 with the power of positive 3 over 2,000. And this will give us a result of 2. So the answer is D. Which of the following is a statement of Ohm's law? So the resistance of conductor is constant. This is wrong because temperature has to be constant. Current in an inductor is inversely proportional to the potential difference across the conductor, provided that the temperature is constant. This is not correct because current is proportional to potential difference. The resistance of a conductor is constant, provided the constant is the temperature is constant. This is correct. Current in an inductor is proportional to the potential difference when temperature is constant. So this is not correct, because if the temperature is not constant, then the resistance of circuit might not be constant, because temperature affect resistance of resistors. Right? So C is the correct answer. A cylinder conductor of length L, diameter D, and resistivity ρ has a resistance R. A different cylinder conductor of resistivity 2ρ, length 2L, and diameter 2D has a resistance of Y. So resistivity is double, so resistance must be double, 2R, and then length is double, so 2R will be double again, which becomes 4R. Diameter is divided by 2, so area will be divided by 4, so 4R divided by 4 will be equal to R. If you don't see this, you can roll the equation out. So for the first part, we know R is equal to resistivity times length over area, which is equal to resistivity times length over diameter over 2 square. This should be a capital D, sorry. And you can move 4 to the top. So this is equal to 4 resistivity times length over pi d square. Right. And then you know the resistivity for the second resistor is double. So it's going to be equal to 2ρ times 2L over pi 2D over 2 square, which is equal to 4ρL over pi D square. And those two quantities are equivalent, so all of them are going to have a resistance of R. So the answer is B. An electron is moving parallel to a straight current carrying a wire. The direction of conventional current in the wire and the direction of motion of the electron are in the same. In what direction is the magnetic force on the current? So there's two ways of solving this problem. The first way is, the conventional current is flowing in this direction. An electron is also flowing in this direction, which means the conventional current is gonna flow in this direction. Current in opposite direction is gonna generate a repulsive force. So it's gonna this current here, this wire here is gonna try to push this electron away. So the force is gonna point in the direction as shown by D. So D is the answer. Another way of thinking about this problem is by using the right-hand rule. Right. So put your thumb in the direction of this current, and then curl your forefinger. Curl your forefinger here, and then we'll find here the magnetic field is pointing downward. Right, it's pointing downward. So for here, you can say it is pointing out of the page. Here is pointing into the page. So the magnetic field is gonna warp it, is like wrap around the wire, and for here is tangent. So it's gonna be pointing downward. So current I is in this direction. Magnetic field is in this. Magnetic field is pointing downward. So I'm just gonna say magnetic field is pointing downward. And then you can find the direction of the force will be pointing in the direction as shown by A, but because it is an electron, so you need to reverse the direction. So F will be pointing in the direction shown by D. A resistor X of resistance R is made of wire length L and cross-sectional area A. Resistor Y is made of same material but has a length 4L and cross-sectional area of 2A. X and Y are connected in series. What is the total resistance of this combination? So resistor X has a resistance R, which is equal to resistivity times length over area. And for resistor Y is going to be equal resistivity times 4L over 2R. So this is going to be equal to rho L over A by having a 2 in front, and it's going to be equal to 2R. Because they are connected in series, then their sum will be equal to R plus 2R. So C is the answer. A cylindrical resistor of volume V and length L has a resistance of R. The resistor has a uniform circular cross-sectional area. What is the resistivity of the material from which the resistor is made? So it has a volume of V, length of L, and resistance of R, and the cross-sectional area is uniform. So how do we find the resistivity from which the resistor is made? So resistance is equal to resistivity times L times area, which is equal to rho times L over volume over length. So this is going to be equal to rho L over volume, and you're going to have L on the top. And this is equal to R. Now I can calculate resistivity. So R times V over L square is gonna be equal to resistivity. So C will be the answer. Two 6-ohm resistors are connected in series with a 6-volt cell. A student incorrectly connect a ammeter and a voltmeter as shown below. The reading on the ammeter and the voltmeter are what? So a voltmeter has infinite resistance, meaning that current will not be able to go through from this circuit, right? So here's gonna be an open circuit, right? So no current will flow in this part. So current is gonna be equal to 0. And voltmeter measures the voltage between two junction point, right? So for here, the junction is here. It cannot go forward because you have a resistor, but here's just wire, so it can continue to go to this point here. So you measure the voltage here, which is just measure the voltage of the battery, the terminal. So it's gonna be B. Ammeter has a current of 0 ampere, and voltmeter measure a voltage of 6 volt. A circuit contains a cell of electromotive force of 9 volt and internal resistance 1 ohm together with a resistor of resistance 4 ohm as shown. The ammeter is ideal. XY is a connecting wire. What is the reading of the ammeter? So current is gonna flow in this direction. So ammeter just measures the current in this circuit. However, here's the wire, right? So current will continue to go here and go here and go here. No current will be going through this resistor here because wire has a resistance of 0 ohm, right? So imagine you have a river, and you have two ways to go. One of them is flat, no friction, and the other one is full of rock. So the river will flow in this direction. And since something was current, it's gonna go through this direction because no current, no electric, there's no resistance in the wire. Right. So now we can calculate the current. Current is gonna be equal to voltage over area. Over resistance, which is equal to 1. So it's equal to 9 ampere. C is the answer. Which of the following is the SI unit of gravitational field strength? So it's gonna be equal to force on a mass, which is equal to Newton over kilogram. So Newton times kilogram was the power of -1. C is the answer. An electron is traveling in the direction shown by the arrow X into a region of uniform magnetic fields. It leaves the region of field in the direction shown by arrow Y. The direction of magnetic field is Y. So in the direction of sine X, in the direction of X, we know this cannot be true, because if it is in the same direction, it's gonna have a degree of 0. And we know force is equal to charge times velocity times magnetic field times sine theta. Sine theta will give, say, a volume of 0. So this cannot be true. In the opposite direction, this also is wrong, because sine 180 degrees is equal to 0 as well. So it can only be B or C. So now I can just use right hand rule. Right. So this is velocity. If it is going to the page, then the force will point upward for a positive charge, but because it's a negative charge, the force will point downward. And for out of the page, your thumb will be pointing downward if it is a positive charge, but because it is a negative charge, the direction is reversed, so F is pointing upward. And here we know an electron is moving up, so it must have an upward force. So D is correct. Three wires, P, Q, and R, carry equal current directed into the plane of the paper. Which arrow correctly identifies the direction of magnetic force on wire P? There's also two ways of solving those. The first way, you can just, by identifying that the current going in the same direction, there's gonna be attractive force. So attractive force by R and by Q. And then you can do force component. So downward force, leftward force, downward force, rightward force. So the only direction of force here is gonna be X. So X is gonna be the answer. Another way of solving this is by using right hand rule. So current is pointing into the page. So let me try to draw this. Current is into the page. So the magnetic field is gonna be something like this. I don't know, just draw a circle. And now I can identify the direction of the magnetic field, and by using right hand rule, you can identify direction of magnetic force. Let me do this. Oh, sorry here. Oh, sorry here. Because the current is pointing out of the page, so the magnetic field should be in clockwise direction. I draw the wrong direction arrow. So it will be in clockwise direction. So it's gonna rotate in this direction here. You can just draw a circle to represent the magnetic field. So here is gonna be the tangent line, which is gonna point in this direction. This is the direction of B field. Now this is current, this is B field. And you can find the direction of the force, which is gonna point downward. And same thing for Q. So you know the force is gonna point downward, so X is the correct option. So B is correct option. What is the equation for the dotted loop? So for this loop, so we know by the loop rule, the total current coming from the terminal will be equal to 0 because of conservation of energy. So here is gonna be 2I. Positive terminal, negative terminal, positive terminal, negative terminal. Here is I3. So 0 is gonna be equal to Y. So here it will be 3I Y with a negative sign, and then flowing this direction to this direction is gonna be a positive sign. And this is gonna be equal to 0. So 4I3 minus 3I2 is gonna be equal to 0. So B is the correct answer. Another way of thinking about this is this. We know the voltage for circuit in parallel is gonna be equal to each other. Then you know 4I3 minus 3I2 is gonna be equal to 0. Right. So two different way of thinking about this, but the same correct answer. The graph shows variation between of current with potential different for a filament. What's the resistance of the filament when potential difference across it is 6 volts. Six volt is here. So here's 6 volt. Let me just redraw this. So it's asking us to calculate resistance, which is the gradient of the graph. I mean, it's the reciprocal of the gradient. So you can calculate the gradient of this graph. Yeah. So find some easy point. Here will be gray, here will be gray. So 8 to 10 is gonna be 2 milliampere. Here and here to here Let me check if this is, yeah, here's the point. It's gonna be what? So here will be 4 volt, and here is what? So 1, 2, 3, 4, 5. 2 volt for 5 interval is gonna be equal to 0.4. So here will be equal to 1.6. So the total will be 5.6. So reciprocal of 5.6 over 2 is gonna be equal to what? Gonna be equal to 2.8. Oh, sorry, here is 2. Made a mistake here. Here is 2. So the total will be 3.6, which is equal to 1.8. And here has the milliampere. Here is volt. Here is volt and. So let me redo this. So here is 3.6 volt over 2 milliampere. Oh, so convert 2 milliampere to 3.6 volt. Which is 108,000. So the closest answer will be D. Two resistors of 10 ohm and 20 ohm are connected in parallel to the cell of a negligible internal resistance. The energy dissipated in 10 ohm in 1 second is Q. What's the energy dissipated in 1 second in the 20 ohm resistor? So energy dissipated is equal to, in 1 second, it's just equal to the power, which is equal to voltage times current. So you know they're gonna have the same voltage. So let's call this P1. P2 is gonna be equal to V times I2, and because they have the same voltage here, so those two circuits have the same voltage, and so their current I2 over I1 is gonna be equal to R1 over R2. So if here in this current is 2I, then here will be I. Right. So let me write this down. 2I. So here's gonna be equal to V2I. So VI 2, and this is gonna be equal to VI. So the power is gonna be equal to Q over 2. With reference to internal energy conversion and ability to be recharged, what are the characteristics of a primary cell? So it converts chemical energy to electric energy initially, and then the ability to recharge, they cannot be recharged. A circuit consists of a cell of electromotive force, 6 volt, and negligible internal resistance connected to 2 resistors of 4 ohms. Okay. The resistance of the emitter is 1 ohm. What's the reading on the emitter? So reading is equal to current 6 volt over resistance sum of the resistance of the circuit. So here is gonna be 4 times 4 over 4 plus 4, which is 2 ohm. So here has a current of 2 ohm. Here has current of 1 ohm. And then your internal resistance, or natural resistance. So the sum of resistance is gonna be equal to 2 ohm plus 1 ohm, so 3 ohm, giving us a current of 2. to isolate charges, -7 microcoulomb and +2 microcoulomb, at which point it's possible for the electrofoil strain to be 0. So A, B, C, D. At which point is it possible? Hold on. Alright, so let's see this problem. So here, negative charge, the electrofoil is gonna radiate inward. Positive charge is gonna radiate outward. So for any point in this region between A and B, they're gonna receive a rightward electrofoil by the negative charge and a rightward electrofoil by the positive charge. So E minus is gonna be equal to K, let's say Q minus or R minus square. E plus is gonna be equal to KQ plus over R plus square. R minus in this case is less than R plus. Q minus is greater than Q plus, which means that E minus will always be greater than E plus. So it cannot be in this region. It cannot be between A and B. So what about the region between B and C? So we're gonna have a rightward electrofoil strains by negative charge, leftward by the positive charge. If I was, it's gonna have two leftward electrofoil. So it definitely cannot be 0. Here is gonna have a rightward electrofoil by positive charge, leftward electrofoil by negative charge. And let's see how this will work out. So in this case, Q minus is still greater than Q plus. So I'm taking the magnitude, and R minus is larger than Q plus. Is this correct? Oh, sorry, I made a mistake here. Q minus is greater than Q plus, and R minus is less than, meaning that E minus might be equal to E plus. So here will be the correct region. Three fixed charge, positive Q, negative Q, and negative 2Q are at the vertical of a equilateral triangle, with the resultant force on an electron at the center of the triangle. So here is a equilateral triangle. An electron is at the center. So how do we calculate this problem? So electron has a charge of a negative charge. So here's the electron. So here's gonna be an attractive force, F1. Here's gonna be a repulsive force, F2. And here is also gonna be a repulsive force, F3. Now we can calculate them. So F3, F2. So because this positive charge and negative charge, they have the same magnitude, right? So you can separate them into different components. So the up this component here will cancel out with this component. So it's gonna become something like this. Right. And then now you can calculate. Let's just say here's the horizontal force. And then you know the net force. The net force is gonna be pointing in this direction. So B is the correct answer. A cell of EMF 4 volt and negligible internal resistance is connected to 3 resistors as shown. Two resistors of 2 ohm are connected in parallel and in series of a resistor of resistance 1 ohm. What power is dissipated in one of the 2 ohm resistor in the whole circuit? Here the sum of the resistance of the circuit is gonna be equal to 2 times 2 over 2 plus 2, which is gonna be equal to 1 ohm. 1 ohm plus 1 ohm is gonna be equal to 2 ohm. So the sum of the current flowing from the terminal is gonna be equal to 6 volt over 2 ohm, which is equal to 2 ampere. Right. And we know power in the circuit is gonna be equal to voltage times current. So 4 times 2 is equal to A. So option A and B, they are both wrong. Now you can calculate in the 2 ohm resistor. So here is gonna be 2 ohm. And because they're gonna have same voltage for circuit in parallel, and they have same resistance, so the current flowing to each 2 ohm resistor is gonna be equal. So it's gonna be 1 ohm. And power is equal to I current squared times resistance, which is equal to 1 squared times 2 is equal to 2. So the answer is gonna be D. Each of the resistors in the arrangement below has resistance R. Each arrangement is connected, in turn, to a power supply of constant EMF and negligible internal resistance. In which arrangement is the current in the power supply greatest? So to find the greatest current, you need to find the smallest resistance, because current is equal to voltage over R. Since there's no internal resistance, it's gonna be equal to EMF over R sum. So sum of resistance in the circuit. So A, because all 4 resistors are connected in series, it's gonna have a resistance of 4R. Here gonna have a resistance of R, so 2R here. And for the 2 resistors connected in parallel, it's gonna be equal to the reciprocal of 1 plus 1 over R plus 1 plus 1 over R, which give us a number of R over 2. So this is gonna be equal to 2.5 R. So for here is gonna be equal to 1 over R plus 1 over R plus 1 over R plus 1 over R is equal to 1 over R sum. So our sum is gonna be equal to R over 4, which is equal to 0.25 R. Here has a resistance of R over 2, and here also has a resistance of R over 2. So the circuit gonna have a resistance of R. So C has the smallest current, which means gonna have greatest current. I mean C has smallest resistance, which means it's gonna have greatest current. A cell is connected in serial with a 2 ohm resistor and a switch. The voltmeter is connected across the cell and reads 12 volt when the switch is open and 8 volt when the switch is closed. What is the internal resistance of the cell? So the voltmeter here measures the voltage of the power supply. So when the voltmeter has a number of 12 volt when switch is open, so no current is flowing through the resistor, and read a number of 8 volt when switch is closed. So now current flow to the resistor. So it lost 4 volt from a open current from an open circuit to a closed circuit. And the loss of 4 volt is caused by internal resistance. So the resistor has a voltage of 8. And you know the resistance of this resistor is 2 ohm. So you can find the current, which is equal to 4 ampere. And now you know the voltage of internal resistance, and you also know current. So resistance is going to be equal to 4 volt or 4 ampere, which is equal to 1 ohm. So the answer is A. A electrical circuit is shown with loop X and junction Y. What is the correct option of curved circuit law for loop X and junction Y? Alright, so let's look at the problem. So current is going to flow in this direction. Here is positive high potential to low potential, high potential to low potential, high potential to low potential here. And for junction Y, so I2, here has a current of I, current of I, current of I. And then it becomes I2 and I3. So I1 is equal to I2 plus I3. It's the sum of the current. I2 is equal to I1 is equal to I2 plus I3. So B is not correct. And for loop X, so loop X. So let's do this. Here is positive terminal and here is negative terminal. So E minus IR I2 R2 minus I1 R1 is equal to 0. So E is equal to I2 R2 plus I1 R1. Do we have this option here? Negative E, this is not correct. E is equal to I1 R1. Alright, another equation we can have is this. E minus, so for here, I3 R3 minus I1 R1 is gonna be equal to 0, which means E is gonna be equal to I3 R3 plus I1 R1. D is also not correct. An electrical circuit is shown with loop X and junction Y. What is the correct expression of the circuit law for loop X and junction Y? So it's saying the current is flowing from the negative terminal to the positive terminal. So here is going to be high potential to low potential, high potential to low potential, high potential to low potential. Here's positive terminal, negative terminal. So from the Loop's law, negative E, here is low potential to high potential, so it's gonna be a positive sign, plus the current I1, R1, plus low potential to high potential is gonna be a plus sign, which means that E is going to be equal to what? E is going to be equal to I1 R1 plus I2 R2. And now let's take a look at the current here. So here's I1, and then it become I2 and I3. So I1 is going to be equal to I2 plus I3. So B is not correct. D is also not correct. Now we only have A and C. And let's do the same thing for this loop here. Negative E plus I1 R1 plus I3 R3 is gonna be equal to 0. So E is equal to E is equal to I1 R1 plus I3 R3. Right. So here's two equations we got. And the other one is this. So the correct answer for this problem will be A. Four resistors are connected as shown. What is the total resistance between X and Y? So we need to find the total resistance of the circuit. So the first thing you can do is find the resistance of those two circuits. So 1 over R sum is equal to 1 over A plus 1 over A, which is equal to 1 over 4. So R sum is equal to 4 ohm. Right. So here it has 4 ohm. And then you can calculate those two. Those two currents. So imagine there's no this current or this current. Right? You only have a current of resistance of 4 ohm. So it's gonna be equal to 6 ohm. Let me erase this. So now here on the upper part is gonna have a resistance of 6 ohm. The lower part also has a resistance of 6 ohm. So it's gonna have a resistance of 3 ohm for the circuit. Because 1 plus A plus 1 over 6 plus 1 over 6 is equal to 1 over 3. So it takes the reciprocal is gonna be equal to 3 ohm. when you have two resistors connected in parallel, any resistor, here's a trick. This is R1 and R2. Our sum will be equal to R1 times R2 over R1 plus R2. And you can do this just by using simple algebra. And if R1 is equal to R2, then our sum will just be equal to R over 2. So remember this. It will help you to solve problem a lot more faster. 3 parallel wires X1, XY, and Z carry equal current into the page, which arrow represents the direction of magnetic force on wire Z. So because they all point into the page, so current has the same direction, meaning attractive forces will be generated. So Z will receive two left force by X and Y. So the answer will be C. Another way of thinking about this is by using right-hand rule. So the current is pointing into the page, the magnetic field will point downward, so left forces will be generated. An electron is traveling in a region of uniform magnetic field. At the instant shown, the electron is moving parallel to the field direction. So here I wrote 180 degree. Then the force on the electron is gonna be equal to 0, because force is equal to charge times velocity times b sine theta, and sine 180 is gonna be equal to 0. A cell with a EMF of 2 volt and negligible internal resistance is connected across 1 meter length of uniform resistant wire XY. The free end of flying by can be connected to any position in the wire. What is the voltmeter reading when the flying lead is connected 0.25 meter from X? So let's assume it's connected to this point. Then what does the voltmeter measures? So to junction point. So it simply measures the voltage of the battery terminal, which has the number of 2. So D is the answer. Two pulses are traveling towards each other. What is the possible pulse shape when the pulses overlap? So it's gonna be A, right? Each of the resistors in the circuit has a resistance of 2 ohm. The cell has an EMF of 3 volt and negligible internal resistance. The ammeter has negligible resistance. What is the ammeter reading? So the ammeter here measures current in the circuit here. And each resistor has a resistance of 2 ohm. So you can calculate the total resistance of the current. So for the upper part here is gonna be equal to 6 volt. For the lower part is gonna be equal to 2 volt, right? So for here it's gonna be 6 volt. So our sum is gonna be equal to 6 times 2 over 6 plus 2, which is equal to 1.5. Right? Now you can calculate current flowing from the positive terminal. It's gonna be equal to 3 over 3 over 2, which is equal to 2 ampere. And because circuit in parallel has the same voltage, then let's call here I1 and I2. So I1 over I2 is gonna be equal to R2 over R1, which is equal to 2 over 3. 2 over 6 is equal to 1 over 3. So you can imagine I has 4 parts, right? Then I2 is just gonna be equal to 2 times 3 over 4, which is equal to 1.5 ampere. So the answer is C. Point P is at the same direction from the two charges of equal magnitude and opposite sign. What is the direction of electric field at point P? So those two charge is gonna produce electric field of same magnitude. So positive charge is gonna radiate outward, negative charge is gonna radiate inward. Now I can separate them into different components. And here in the vertical direction it cancels off. So the electric field is pointing to the right direction. A is the answer. The graph shows the variation of current I in a device with potential different V across it. What is the resistance of the device at point P? So resistance is equal to voltage over current. At this point has a voltage of 20, resistance of 2, so it's gonna be equal to, current of 2 ampere, so resistance is gonna be equal to 10 ohm. Which of the following gives the resistance of an ideal ammeter and ideal voltmeter? So for ammeter, it's gonna have 0 resistance because you want to measure current. Voltmeter, you're gonna have infinite resistance because you don't want any current to flow from the device. A wire has variable cross-sectional area. The cross-sectional area at Y is double at X. So X has an area of A, Y has an area of 2A. At X, the current in wire is I, and the electron drift velocity speed is V. What is the current and electron drift velocity at Y? So since they're in the same wire, current will be same at any point in the wire, meaning that at X it's gonna have a current of I, at Y it's also gonna have a current of Y. So C and D is wrong. So current is equal to number of electron times charge times cross-sectional area times drift velocity. Right. So at X is gonna be equal to at Y. So since the area is double, then the velocity must be divided by 2. So B is the correct answer. Which arrow shows the direction of magnetic force experienced by Y? So since Y and Z, they are both pointing into the page, an attractive force will be produced. Y is pointing out of the page, a repulsive force will be produced. But because Y is closer to Z, so the force will be pointing to right. So A is the answer. And you will see why when you are getting deeper to electricity. So there's magnetic force due to a thin wire. There's a formula to calculate that. Where R is the distance between two currents. Right? So you'll learn more about electricity when you go deeper. Which nucleon in a nucleus are involved in Coulomb interaction and strong short range nuclear interaction? So proton is involved in Coulomb interaction, and proton and neutrons are involved in strong short range interaction. So the answer is A. Which of the following is the best representation of electric field lines around a negative charged metal sphere? So it's definitely gonna radiate inward and no field line inside the sphere. So B is the answer. An ideal ammeter is used to measure the current in a resistor. Which of the following gives resistance of an ideal ammeter and the way it connects to the resistor? So 0 resistance and connected in series. The graph current versus voltage. The graph shows the current versus voltage characteristic of two resistors. When resistor X and Y are connected in series, the current in the resistor is 2 ampere. What is the resistance of the series combination of X and Y? So if they're connected in series, you can find their voltage separately according to the graph. So it's 2 ampere, voltage of 4, and voltage of 10. So the total voltage is going to be equal to 14 volt. And now we can find their resistance. So 14 divided by 2 is going to be equal to 7 ohm. So A is the answer. Which diagram represents the pattern of electric flow line between two small positive point charges hold at the position shown? So here is wrong. Two positive charges gonna repel each other. For B is also wrong because positive charge, their electric flow line really outward. Here is also wrong because they will actually like curve like this. So B is the correct answer. A battery of 2 volt and negligible internal resistance is connected to a resistor of constant resistance 6 ohm, an ideal ammeter and an ideal voltmeter. What is the rating on the ammeter and on the voltmeter? So since here's a voltmeter, is gonna have infinite resistance, meaning that no current will flow in the circuit. So here's gonna have a reading of 0 ampere. And what about the voltmeter? So the voltmeter here is just gonna measure the voltage of void. So voltmeter here, is gonna measure the voltage of the battery terminal, which has a voltage of 12. So it's gonna be answer D, 0 and 12. Right. So you need to be able to identify what voltage is the voltmeter measuring. Right. A long straight current carrying wire is placed between an iron of metal shown. What is the direction of the force on the wire? So north pole, south pole, electric flow line, a magnetic flow pointing from north to south, current flowing into the page in this direction. So your thumb will be pointing downward if you use right hand rule. So they're asking what's the direction of the force on the wire. So it's gonna be a downward force. Right, so C is the answer. A wire carrying current I is placed in a region of uniform manifold B, as shown in the diagram. The direction of fill line is out of the page, and the length of wire is out. What is correct about direction of manifold of force acting on the wire? So we know the direction can be find by using left-hand rule. So this is the current, this is the magnetic field. So what about the force? So it's gonna be something like this. And for the force, it's just gonna be equal to current times length times magnetic field times sine theta. The sine theta is just gonna be equal to sine theta is gonna be equal to 0 in this case. So the answer will be A. A long straight wire carries the electric current perpendicular out of the paper. Which of the following represent the manifold pattern due to the current? So it's upward, so point your thumb in the upward direction, and your forefinger is gonna be in the counterclockwise direction. So D is the answer. So identical filament lamp, X, Y, and Z are connected as shown to a battery of negligible internal resistance. The filament of lamp X breaks, and which the following correctly describe the change in the brightness of lamp X and lamp Z. So let's just see what's gonna happen. So X is break. So here is gonna be current I flowing I1, I2. X break. If X break, what happens is resistance of the current decreases. Increases, sorry. So current I will decreases. And we know resistance remain fixed. So power is equal to voltage times current, which is equal to current square times resistance. For Z, power is gonna decreases because the current decreases. But for Y, the power is gonna increases. Right. So why does the power increases for Y? So we know they have they're identical, right? So if current I is flowing here, then here is gonna be a half I for I1, I2. So and then if here is broke, right, the current flowing to lamp Y is gonna increases, and you can actually prove it. So before it broke, right? Before it broke, current is gonna be equal to voltage over 1.5 Y times a half, and this is equal to V over 3R. But after it broke, it's gonna be equal to V over 2R. And this is the current for that goes through resistor Y before lamp X is broke, and this is current after lamp X is broke, the current that goes through Y. So for Y, the power increases because current increases. So brightness increases. So Y increases, Z decreases. Y increases, Z decreases. So the answer will be C. A lamp is connected to an electric cell and it lies at a working voltage. The lamp is then connected to the same cell in a circuit with an ideal ammeter and an ideal voltmeter. Which circuit allowed the lamp to lie at its original brightness? So for this circuit here, all current will flow from the ammeter because it has zero resistance, and this is why ammeter must be connected in series with a electric device. For here, B is correct because current will go through the ammeter, go through the lamp, and the voltmeter will measure voltage of the battery terminal. For C, no current will go through the circuit because voltmeter has an infinite resistance. For D, same thing. All current will go through the ammeter, so no current will be going through the lamp. So B is the answer. Which of the following is the correct way of connecting an ammeter and connecting a voltmeter? So ammeter must be connected in series with something. Right? So B and D is definitely wrong. Voltmeter must be connected in parallel, so no doubt the answer is